So we stopped on extracting architecture characteristics or quality attributes from concerns. Let's quickly remind what we are talking about, and we will continue. So, as a designer of the system, you have to be able to translate domain concerns to identify the right quality attributes, the right characteristics, the right non-functional requirements. For example, is availability the most important concern, or it is, for example, performance or security and so on? Perhaps the system requires all characteristics to combine. But understanding the key domain goals and domain situation allows you as a designer to translate those domain concerns into a specific form that you will be able to correct in future. One of tip when collaborating with domain stakeholders to define the driving architecture characteristics is to work hard to keep the final list as short as possible. A common anti-pattern in architecture is trying to design a generic architecture, one that supports all the characteristics. Each architecture characteristics is architecture supports complicates the overall system design. Supporting too many of them leads to greater and greater complexity before the designer, the architect, the developers have even started addressing the problem domain. So don't try to make things more complex as they should be. It means that maybe if you will not highlight the most important quality attributes, you will produce a lot of unnecessary frustration and disagreement with the key stakeholders. Rarely will all stakeholders agree on the priority of each and every characteristics. A better approach is to have the domain stakeholders select a top 3 most important one from the final list. Maybe even in any order. Not only is this much easier to gain consensus, but it also have to be a discussion that will help you to analyze trade-offs between your future decisions. So as you see on this table, for example, if you will hear during this communication that time and budget is the key point, then for you it means that simplicity and feasibility is most important. Now let's move to another step. It is specifying quality attributes requirements. They have to, these quality attributes or architectural characteristics, they have to be testable. We have to use a common form to specify all quality attributes requirements. This has some advantages and disadvantages, but there are some key aspects while we have to follow with the strict rules. The common form of quality attributes expression has next parts. It is source of stimulus. This is some entity that generate the stimulus. What it means? A stimulus must have the source. It must come from somewhere. The source of the stimulus may affect how it is treated by the system. What it is stimulus? So we will use term stimulus to describe an event arriving at the system. The stimulus can be an event to the performance community, a user operation to the usability community, or for some attack on the security, and so on. Next one is environment. So environment of requirement is a set of circumstances in which the scenario takes place. The environment acts as a qualifier on the stimulus. Some examples. Of the request for some modification that arrives after the code has been frozen and released may be treated differently. So yeah, it's better to, I will show you examples a little bit later, you will see. Artifacts. Artifacts, it's finally the artifact is a portion of the system to which the requirements apply. So it can be some executable component. And the next one is response. What it is response. So response, how the system should respond to the stimulus. It must also be specified. The response consists of responsibilities that the system or of the system or the developers should perform in response to some stimulus. How it should respond to performance stimulus, how it should respond to scalability stimulus, and so on. The response measure. It determines whatever the response is satisfactory, whatever the requirements is satisfied, is enabled to by providing a response measure. That's all about the measure. How, for example, for the performance, the request was handled for 5 milliseconds, or for availability, the system was available for example, 24 hours per day, or something like this. This is general case, but based on this general case, this general quality attribute scenario can be represented in this way. So we have source of stimulus. It can be a person, it can be another system. We have different kind of stimulus action that was generated, some request, for example. We have artifact on which the stimulus was, where we made some action. We have to describe these artifacts. It can be in different environments. So we have to also specify in which environment and what response we are expecting to do. And let's measure this response. Generally, why we are talking about this approach, this is one kind of the solution that can make understanding of quality attributes more simple and understandable for different persons. One of the person can understand availability from one perspective of view, another one can understand from another perspective of view, and so on. So you will have different opinions, even for one quality attributes or architectural characteristics, whatever. Here is the option how to make this understandable, more clear for all stakeholders, for all participants, that they will understand how should they read each of them. So how should they understand performance from the perspective what kind of stimulus it was, for what artifacts, in which environment, what response we should expect from this stimulus, and how we can measure our response. Based on that, when we will then it will be much more clear what can we what it is the system is quite performant, or system satisfy these performance needs, or system satisfy availability requirements, and so on. If we will have this response measure, then at the end we can answer the question: does the design system answer for, or not answer, but correspond to these design measures or not? If not, it's not acceptable. If yes, then that is expected from us. Let's I will try to give you some example. For example, if you will talk with customer or as one of the stakeholders, and he will say that we need the system that it will work quite fast. So the request will come, they will handle quite fast. What it means, quite fast. So you have to understand that this is about performance, but 1 month, is it fast? If the user click button and will wait 1 month during the response, I expect that answer will be no, for sure no. Okay, 1 week, 1 day, no. 1 hour, 1 minute. What means fast? What is fast for that particular person? What he expect, what the customer expects from us. We have to clarify it, and this is one of the proposal approaches, how you can manage all of these cases, that at the end of the implementation of the system, you can evaluate the solution and say that it is satisfied to what was expected or not. This is strict structures that will help you to talk not in quite abstract language, but to be more concrete is in this quite sensitive area. So based on this general quality attribute scenario, we can create, it will help us to create concrete quality attribute scenarios. Here is the example for availability. You can see here that, for example, for source of stimulus, it can be internal or external. It can be people, hardware, software, physical infrastructure, physical environment. The stimulus can be fault, mission crash, incorrect timing, incorrect response, artifacts, processors, communication channels, environment, normal operation, startup, shutdown, repair mode, and so on. So this is concrete quality attribute scenario for availability. Response, it can be prevent fault from becoming failure, detect fault, log, notify, recover from fault, disable event source. Response measure, time or time interval system must be available, availability percentage, time in degraded mode, and so on. So based on this schema, you will be able, based on general scenario, will be able to create concrete. Generally, the previous one, it was part of it was the schema, and this one it will be more better to say this is a general scenario for availability on the image. It's not exactly concrete, because concrete, how will the concrete quality attribute scenario will looks like? You will be able to select one of these, one of the available options, if you will learn all of them, to build your concrete scenarios. For example, you can say that, okay, in my particular case, we're talking that the source will be external, and stimulus will be this one. It will be normal operation on communication. And so you will choose from the general scenario, you will choose concrete things to describe your cases according to your domain and what you are expecting. How can you, the next question is, okay, so we'll start understand, we'll have some vision about how we can structurize our expectation from stakeholders to particular quality attributes. But what will be the next step? How can we achieve this expectation? And This expectation can be achieved by tactics. What it is tactics? The architectural tactic is a design decision that affects a quality attribute response. So this is some of the decisions that will affect your architectural characteristics. You know that you have to achieve these characteristics. Some of them is more important. You already highlighted. And for each of them, there are different tactics that you can apply. You have to know these tactics. You have to understand these tactics as like design decisions, and to understand that in this case, this kind of decision will be correct. And they should be applied to achieve expected quality attributes. But in another case, it's not possible to build generic systems that will satisfy everything. In some cases, one decision is suitable more for achieving particular results. In other cases, completely different decision is more suitable than others. So this design decision is tactics. The focus of tactic is on a single quality attribute response. They focus on single quality attribute response. Within the tactic, there is no consideration of trade-offs. Trade-offs must be explicitly considered and controlled by a designer. So in this respect, tactics differ from architectural patterns. Don't mix it. There is a little bit difference between, not a little bit, there are difference between them, where trade-offs are built into the patterns. So how can I describe it? So maybe it will be a little bit hard for the first step to choose exact pattern that combine different tactics, different decision that will suit to quality attributes that you want to achieve. And as an intermediate step, you can move using the tactics. You know that in this case, you can use some of them, and some of them is more suitable for you. You already some decisions, and based on these decisions, you can choose what kind of patterns in the next steps you will use. We are talking about the architectural patterns. We are not talking about class patterns like creational, structural behavior. Yeah, but by the way, yeah, some of them also can be applied even on that level. So architectural patterns can be seen as packages of tactics. What else? So yeah, I believe let's move forward. Another one key point is that when you will determine the tactics is that look, there is the thing that can help you to make this design decision. This is like some guidance of quality design decisions. It is proposed the general schema that will apply in a different way for particular characteristic, for particular quality attributes. But the general view can look in next way. It will contain 7 categories of design decisions that are, first of all, it is allocation responsibilities, for example. So using allocation responsibilities, decisions involve allocation, and responsibilities include the following. It's identifying the important responsibilities, including basic system functions, architectural infrastructure, and satisfaction of quality attributes. It is determining how these responsibilities are allocated to non-runtime and runtime elements. Another one is coordination model. So coordination model, what it is. Decisions about coordination model, they includes, for example, identifying the element of the system that must coordinate or are prohibited from coordination, determine the properties of the coordination, such as timelines, currency, completeness, correctness, consistency, choosing the communication mechanism, this kind of coordination, data model. what kind of decision can be for the data model? Choosing the major data abstraction, their operation, their properties, compiling metadata needed for consistent interpretation of the data, organization of the data, management of resources. This kind of decision that it can looks like identifying the resource that must be managed and determine the limits. But by the way, this is one of the one of the possible tactics that can help you to solve, for example, performance issues. And so on. So bidding time decision. Maybe we will need to take a look at on the examples, I believe. Before, yes, next part, it will be availability. Let's make the pause before we will switch to this part. So I will stop the recording.